Okay, welcome to this question involving Pythagoras theorem and limits of accuracy. Okay, I've just made this one up a few minutes ago, but we're going to do this now. I'd strongly encourage you to have a go first yourself before you let me explain it all to you. All right, once you've done that, start the video again and watch it. The diagram shows the route of a boat from A to B to C and back to A again. Okay, it travels 7.1 kilometers north, if you like, 22.4 east, and then it's straight back to base. Okay, in a straight line. Now it's telling us that these distances are given to 0.1 kilometers, and the journey time to two significant figures was 2.1 hours. Okay, so what we need to know is what's this distance here, first of all, okay? But we need to know the upper and lower limits or upper and lower bounds of the distance. Okay, so we're not actually going to use 7.1, 22.4 or 2.1 in any calculation in this problem, okay? We're just going to use the upper and lower bounds. So we hopefully know that if these have been given to 0.1 kilometers, then the lowest that could be is 7.05 and up to 7.15 as the maximum. This is 22.35 to 22.45. Okay, so we need to work out I'm going to work out the maximum, or sorry, the minimum first, the minimum x. So I'm going to put x lower bound. XL means lower bound of x, all right? Okay, so here we go. It's Pythagoras theorem. It's a right-angled triangle. So I need to do the square of 7.05, okay, squared, plus the square of 22.35, okay, squared. And I need to square root that to get the lower bound of x. Okay, put it in a calculator and you get 23.4355. Okay, 23.4355, and it does go on after that, but that will do to 6 significant figures. All right, and I'm just going to say 6SF because I have rounded it, you see. Okay, now the XU is the upper bound of x, the maximum it could be, which is going to be the same kind of thing, except I'm going to have 7.15 squared plus 22.45 squared. And when I put that into the calculator and evaluate it, I get 23 point, and this is a bit bigger, it's 23.5611. Okay, 5611 to 6 significant figures. All right, so you must show all this working out. You can't answer a question like this without showing all this working. Right, now I want the total journey, not just x. So obviously to get the longest possible journey, I would add the upper bounds of all three together, and to get the lowest minimum possible journey, I would use the lower bounds. So let's do the journey. Now what can I call it? I need to give it, I'll just call it journey. So if I say the minimum journey is going to be, well, it's going to be my 23.4355, 23.4355 plus my 7.05 plus 7.05 plus 22.35. Okay, and that comes to 52.8355. 52.8355. Again, 2 6 significant figures. And the maximum journey, okay, that's the longest possible distance it could have been between those 3 points, is going to be 23.5611 plus 7.15 plus 20, that's 7.15, that should be 7.15 plus 22.45. Okay, and that comes to, on the calculator, that comes to 53.1611. 53.1611. Okay, now we need the maximum and minimum speeds, or I could call it the, so if we know distance equals speed times time, then speed is distance over time, okay? Distance over time equals speed. All right, I'll just take that out. Distance over time is speed, so basically the speed, we want the speed of the lowest possible speed, the lower bound, okay? And that's going to be, that comes from the minimum possible distance divided by the maximum possible time. So we want the minimum distance, all right, which is 52.8355, 52.8355, divided by the maximum possible time it could have taken, which is 2.15 hours. Okay, that's the upper bound of 2.1 if it had been rounded to two significant figures, you see. And that comes to 24.57, 24.5747, and then it goes on, but that's more than enough accuracy for this part. And then we want the SU, which is the upper bound of the speed, the maximum possible speed it could have been, and that is 53.1611, 53.1611 divided by 2.05. Okay, and if we put those together in a calculator, we get 25.9322. Okay, and they're both in kilometers per hour because it's distance divided by time, and those are the speeds, possible maximum, possible minimum. Right, so the question is, who's right, if any? The boat owner claims that the speed of the boat was 25 kilometers an hour. Well, that's given to two significant figures, right? Well, if we come here, 24.57 to two significant figures is 25. So that's great. It seems right. What about this one? 25.9. The speed could have been as high as 25.9. If it was, or indeed anything over 25.5, we couldn't have claimed the speed was 25. We would have had to say 26. So this could be right, but it's not for sure because of the upper bound of the speed exceeding what we need to round to 25. Okay, so that's wrong. What about the mathematician? Ought to be correct, really. Should be no question about it, but let's see. The mathematician says that it is 20 kilometers an hour to one significant figure. Well, that is because 24.57 is 20 to one significant figure. In fact, anything up to 25 is 20 to one significant figure. But as soon as you get to 25 and above, then that would have to round to 30. So to one significant figure, this is not 20, it's 30. So I'm afraid the mathematician is wrong too. Are any of these claims correct? No, they're both wrong. Okay, justify your answer. Now this is the bit that people don't like because it means they've got to think and write things down, which might take a little bit of time. But I'm afraid if you want the marks, that's what you have to do. So how are we going to justify it? We need to make some kind of statement that shows we understand all that rounding stuff. Well, look, I'm going to say that 24, so the answer's no, right? Let's just put that there. And the justification, so this is my answer down here. I don't know why I'm doing it down here, but I am, so I'll carry on. So my answer is no. 24.57 equals 25 to 2 SF. Okay, but 25.93 equals 26 to 2 SF, which does not equal 25. All right, and the second part of my answer is going to be that 24.57 equals 20 to one significant figure, but 25.93 equals 30 to one significant figure, which does not equal 20. That's my justification. All right, now that is annoyingly close to this, so I'm going to just put a box around it in a different color just to separate it out. And oh, look at that. I'm going to have a sloping box, which is even worse, but I'm going to have to do it now. So there we are. The layout of that doesn't get full marks, but the answers are correct. Okay, so justify your answer. You have to do something, and you have to sometimes state the obvious. 26 is not equal to 25. Well, okay, but it isn't, so we must say that. Okay, that's the end of that question. And thank you for listening, watching.